Hello students, Namaste parents and educators. Now I am going to discuss about ionization energy. Ionization energy is minimum energy required to remove, needed to remove, take out an electron. This point is important. An electron, single electron should be removed at a point of time, alright, from outermost shell, from valence shell, alright, outermost shell of an isolated gaseous atom in its ground state. Condition is this one, isolated gaseous atom in ground state. That means whatever the atom is from where you want to take out an electron, you want to ionize it and you want to check the energy transfer, what is happening there. Condition should be the atom should be in gaseous state and it should be isolated. Isolated means it should not have any interaction with other atoms or other molecules. That means energetically it should not be interacting with any different species. Energy interaction is there. It is related to the atom and its ion. Alright. Then only we can term that energy as ionization energy. Alright. I have put these bullet marks here because these all terms is important for ionization energy. Alright. Now let us try to understand this ionization energy using some examples. First example is sodium. Alright. Sodium has 11 atomic number. 11 protons will be held inside the nucleus of the atom and 11 electrons will be revolving around the nucleus. Alright. It will be revolving outside the nucleus. Alright. So all the electrons are held by a nuclear pull. They feel attraction from the 11 protons of the nucleus. Alright. So there is force of interaction, force of attraction between electron and the protons. Alright. Overall, you can call this as nuclear pull. So if you want to remove the last electron, if you want to check the last electron here, you should think in terms of its electronic configuration. Principal quantum number 1, n equals to 1 will have 2 electrons, n equals to 2. Principal quantum number 2 will have 8 electrons and principal quantum number 3, n equals to 3 will have 1 electron. 11 electrons will be arranged in this manner. Alright, okay. So this last electron, we have to remove this last electron. Alright. So in order to remove the last electron, we need to provide some energy because this last electron is also feeling some attraction, force of attraction from nucleus. So if you want to remove that electron, you have to break that force of attraction between the last electron that attraction it is feeling and the nucleus. Alright. So you have to provide some energy. This process will be endothermic, not exothermic. Alright. That is why energy, you need to put some energy, you need to add some energy for ionizing this particular sodium atom. Alright. It is already in the mentioned state, isolated gaseous atom and in its ground state. Alright. No more energy interaction is there apart from this energy. Alright. Okay. So whatever this energy has been required in this particular case, it is completely used in converting this Na gaseous atom, sodium atom in gaseous state into the ionized state. Alright. So now one electron has been lost. Electronic configuration will be 2, 8, which is the electronic configuration of nearest noble gas for sodium, and this is its stable state. Alright. Now if you want to remove another electron from here, you will require a very high amount of energy with respect to this energy. Alright. This is important here. Alright. Let us take some more example of some different element. One more part is important here. Metals have tendency to lose electron and non-metals have tendency to gain electron. Alright. So metals, for metals, if you want to check about the E value of metal, generally they will be lower magnitude, they will be of lower magnitude with respect to the element which are non-metal, and you are trying to check about its ionization energy. Alright. Non-metals have a tendency to gain electron rather than losing electron. Alright. This is the concept behind it. Alright? Okay. So now let us check about this calcium atom. Calcium atom also we have taken it in gaseous state, isolated gaseous atom, and it is in ground state. Now we are providing some energy. At a point of time, we need to take out one electron at a time. Alright. So that is why we have two steps here. Calcium has atomic number 20. And if you want to check about its electronic configuration, it will be 2, 8, 8 and 2. Alright. So, n equals to 4, principal quantum number 4 will have 2 electron. Alright. So, that is the outermost shell and it has 2 electron now. So, any 1 electron will be taken out when energy E1 is provided. Alright. So, this is termed as first ionization energy. Alright. Now, the electronic configuration here should be 2, 8, 8, 1. Alright. So, last shell n equals to 4, principal quantum number 4 will have 1 electron left. Alright. Now, we need to remove that electron also so that this Ca plus can attain nearest noble gas configuration, which is configuration of argon, 2, 8, 8, and this whatever energy is required here, this is termed as E2. One important thing is there, E1 and E2 will not be equal. Alright, that is why I have denoted it with E1 and E2. E1 is known as first ionization energy, E2 is known as second ionization energy. You can denote it with I1, I2, that is fine. Alright, if you take example of aluminium, aluminium will include one more step because in order to attain its nearest noble gas configuration, it has to remove 3 electrons. Alright, so 3 steps will be there. Alright, and if you add these 2 steps, what we are going to get is Ca gas, Ca plus will be cancelled out, plus E1 plus E2, total energy E1 plus E2 will be required, and we will get in product Ca2 plus gaseous ion plus 2 electron will be lost in that case. Alright, but if you want to check about the ionization energy value, you have to go into these first ionization energy and second ionization energy. Alright, so these are the important point from here. Now let us check about if they are not equal, can we compare them? Can we tell which one will be greater? Alright, so can you try to think about it, which one will be greater, E1 or E2? So if you want to check about this thing, which energy will be greater, I am just writing important things here. Ca, gaseous, isolated gaseous atom in ground state has been taken. E1 energy has been added to convert it into Ca plus gas. Alright, okay. So in this step, E1 energy was required. Alright, and the step where E2 energy was required is this one, Ca plus gaseous. Alright, and now we are converting it to Ca2 plus. It has lost one more electron. Alright, and now it has attained stable electronic configuration. Here the configuration is 2881. Here it is 2882. Alright, here it is 2, 8, 8, 1. Here it is 2, 8, 8, 1. Alright, okay. Now, Ca gas, it will have 20 proton and 20 electron. Alright, and the last electron, any one of the 2 electron is being removed in this case. It was neutral. Ca, isolated gaseous atom, it was neutral. Alright, and in this case, it is Ca plus. That means this Ca has already lost an electron. Alright, but protons are still intact. 20 proton will be there in the nucleus. Alright, 20 proton is holding 19 electron now. So the last electron, the 19th electron, it will feel more nuclear pull. If you want to go in terms of C effective, Z effective, so it will be increased now. Alright, nucleus will be holding this last electron more effectively with respect to these 2 electrons. Alright, because number of proton is greater than number of electron now. Alright, okay. So if you want to take out this last electron, it is feeling more nuclear pull now with respect to these 2 electrons. So you will need to provide more energy to break that force. of attraction between the last electron and the protons which are there in the nucleus. All right. So this is the main part here. E2 will always be greater than E1. All right. In case of aluminium, if you want to check, there will be third ionization energy. All right. So E3 will be greater than E2. It will be greater than E1. All right. You can think about it. It is a simple thing. You can easily relate this point. All right. Now let us try to relate about the trend of ionization energy in periodic table. If you move from top to bottom in a group in PT, in periodic table, metallic character increases. As metallic character increases, metal has a tendency to lose electron. Very nice metals will be easily losing electron. Alright, that means lower energy will be required by good metals. Alright, the metal which are having very nice metallic character, they will require less energy and they can easily lose electron. Alright, so metallic character increases if we move from top to bottom. So ionization energy will decrease. It will not require more energy now. All right. And if you move from left to right in periodic table, non-metallic character increases and metallic character will decrease. All right. For that reason, ionization energy will increase. And diagonally, if you want to move from upper right corner to lower left corner of PT, ionization energy will decrease because metallic character increases. This corner will have very nice non-metals. Okay, one more thing, group 18 is not involved here. Alright, noble gas is not involved here. Till group 17, if you want to check, these corner will have very nice non-metals. Alright, and the bottom left corner, it will have very good metals. Alright, so ionization energy decreases if you go in this manner in periodic table. This is the general trend. Alright, okay. Thank you so much with such concept and some questions. I will be there in next video. Thank you.